today's chemistry tutorials. I am Ben Benjamin. In this video, we will learn elements and their symbols. Firstly, let us define an element. An element is a substance which cannot be split into simpler units by an ordinary chemical process. That means an element could be considered as the smallest, as the building blocks of other substances. It is the fundamental by which other substances are created. Now, let us consider symbol. Symbol of an element is the shorthand notation or a label which represents a particular element. You can see that it was difficult for scientists to work in the laboratory, write a chemical equation with the names of these elements. It was too cumbersome to do so. So scientists decided to give notation to each element. But in the 19th century, the early 19th century, it was John Dalton that actually started the work of giving symbols to each element. In his notation, hydrogen was given a 0 with a dot, as you can see here. Carbon was given a 0 that is painted all over. Sulfur was given a 0 with a cross inside. Nitrogen was given a 0 with a single bar. Sodium was given a 0 with a double bar, and potassium was given a 0 with 3 bars in it. This was very, very difficult to understand, as most of these symbols were not related in any form to this element. In the still early 19th century, to be specific, in 1810, a man known as Berzelius was working to confirm John Dalton's atomic theory and other work in the laboratory. He came to a conclusion that the existing method or system of denoting elements was a hindrance. He came to the conclusion that it is easier to write an abbreviated word than to draw a figure which has little or no relationship with the word. You choose letters from the name of each element instead of figures. These letters is a symbol for each element. As we can see in the table that we're going to display for you to see, each element was given a notation which was extracted from the name of such element. And this notation was very unique to that particular element and differ from others. Thus, Berzelius divided the element into 4 categories. The first category of elements, I can call it group the A category. Now, the A category were those elements whose symbols were derived from the first letter of their names. In this derivation, you can see that each element was given the first letter of its name, and that was written in capital letters. You can see that according to here we have element, symbol, and then according to the atomic number in the periodic table. We have hydrogen, the symbol is H and the atomic number is 1. Boron have B, the symbol is B, then the atomic number is 5. Carbon is symbolized C with atomic number 6. Nitrogen N, atomic number 7. Oxygen O, atomic number 8. Fluorine F, atomic number 9. Phosphorus with P, atomic number 15. Sulfur with S, atomic number 16. Vanadium with V, atomic number 23. Yttrium with Y, atomic number 39. This is not the all element with this notation of giving the first letter as a symbol. There are many others in the periodic table, but for easy understanding, we'll be able to present the following for you. Now, the second category were those ones that were given the first letter and the second letter of their name as a symbol. For example, in helium, you can see that helium, which is atomic number 2, was given the symbol H and E. In this category, in writing the symbol of a particular element, you choose the first letter to be in capital letter and the second letter to be in small letter. This is correct. But if you write like this is wrong. If you also write like this is also wrong. If you write like this, it's also wrong. But this is correct. Now, let's go back to the table and observe other elements with this kind of notation. Now we have here helium as He, and in the position is 2 in the periodic table. Lithium Li and position 3. Beryllium Be, atomic number 4. Neon Ne, atomic number 10. Silicon Sr with atomic number 14. Argon is Ar, atomic number 18. Calcium is Ca with atomic number 20. Scandium is Sc with atomic number 21. Titanium is Ti, atomic number 22. Cobalt is Co, atomic number 27. Nickel is Ni, atomic number 28. Gallium is Gr, atomic number 31. Germanium is Ge, atomic number 32. Selenium is Se, atomic number 34. Bromine is Br, atomic number 35. Krypton is Kr, atomic number 36. Molybdenum is Mo, atomic number 42. And ruthenium is Ru, atomic number 44. Like I said, these are not the only ones in the periodic table, but we've been able to extract this one for you to understand why these elements were given these symbols to represent them. Now let us move to the category C. In the category C, as you can see in this table, the elements were given the first letter of their name and any other letter of the element's name apart from the second letter of the name. As you can see here in this table, magnesium was given Mg instead of Na, but it was given Mg. So elements in this category are given the first letter and any other letter other than the second letter. So magnesium, in this case also, you are going to write the first one to be capital letter. In this magnesium is given M as capital letter and G in small letter. This is wrong. This is right. This is also wrong. This is right. The first letter in capital letter and the small letter in small. The first letter in capital letter, the second letter in small letter. So we have magnesium Mg, atomic number 12. Aluminium is Al, atomic number 13. In the case of aluminium, please, it is wrong to write A and L, but it is A with small letter L. Now we go to chlorine, Cl. The same thing with chlorine. You don't write C and capital letter L. This is wrong, but this is correct. Capital letter C and small letter L. Chromium, the same thing, Cr, atomic number 24. Manganese is Mn, atomic number 25. Zinc is Zn, atomic number 30. Arsenic is As, atomic number 33. Rubidium is Rb, atomic number 37. Strontium Sr with atomic number 38. And zirconium Zr, atomic number 40. However, there were other elements whose symbol could not be derived from either category A, B, or C due to the fact that other elements maybe have already taken this letter. For example, sodium could not be given a symbol of S or maybe SO. These would have contradict sulfur. And so elements in this category were given symbol from their Latin or German or Greek names, as we will see in this table. Now here, you can say sodium was not given the symbol SO or SD or S. Rather, the symbol is Na, which is derived from the Latin name, which is natrium. And sodium is element 13. Now coming to potassium, the Latin name is kalium, and the symbol is derived from the K with atomic number 19. Iron is derived from the Latin name ferrum, which is Fe and atomic number 26. Then copper is coprum, Cu with atomic number 29. Silver, argentum, Ag with atomic number 47. Tin, stannum, Sn with atomic number 50. Antimony, stibbium with atomic number with symbol Sb, atomic number 51. Gold is aurum with Au as a symbol, atomic number 79. Mercury is hydragenum with Hg, 80 is the atomic number. And lead is splendum with Pb, atomic number 80. As you can see, that most of them, like sodium, iron, copper, silver, and the rest of them, the first letter of the Latin name which the symbol is being derived is in capital letter. For example, copper, which is coprum, the first letter is in capital letter, and the second letter from the Latin name coprum is in small letter. That is how it is written. I believe we have touched the elements and their symbols. We're able to define elements and look at the symbols and how they were given to each element. And so, in the next video, we shall be looking at how symbols can be used to compose or to write a chemical formula, the formation of a compound. Please subscribe to our channel for more videos. Thank you.